This is Tim Lally, and I will be talking about developing applications in Dexterity over this multi-part series. What is Dexterity? Dexterity is a development tool that was developed in the early 90s by Great Plains to develop the product that is today called Dynamics GP. The purpose of creating Dexterity was to have a 4GL development environment that was easy to learn and allow new functionality to be developed quickly. Dexterity applications is made up of objects that can be used over and over again throughout the application, and the coding is called Sanskrit and can be compared to maybe a Pascal type language. Dexterity can be used to build standalone applications, but its real purpose by developers is to customize GP. So let's take a look at Dexterity. Assuming that you have already installed Dexterity from the Dynamics DB download, but if you haven't, it is located in the Tools directory of the download file. So let's launch Dexterity. When launching Dexterity, you get prompted to open an existing dictionary. We can create new dictionaries or create an empty dictionary if we want to build a standalone brand new application, but like I said, we will be modifying the Great Plains dictionary. So I'm going to go find my dictionary out there on my drive. Now what I typically do is I copy the Dynamics dictionary from my Great Plains install so that I don't contaminate my environment and I have something I can test with. So I'm going to pick my Dynamics dictionary, open it. Now when we open Dexterity, you're presented with what they call the Resource Explorer. And the Resource Explorer is all of the components that make up a Dexterity or a Dynamics application. So as you can see here, and to keep it simple, we have a variety of components that make up the application. Let me stretch my screen out here so we can see as much as possible. So don't worry about the application because the application is basically the application itself. The product install, we generally don't add any more components to this piece of the resource. Down here in the base, we have a variety of different things that make up the application. The first is a composite, and a composite is a resource that is made up of multiple fields. An example would be a segmented customer number. Your account number in Great Plains is a composite field that's made up of multiple fields in the system. That's a composite. There's not a lot of composite fields in the system, but they do come in handy sometimes if you need them. Constants. Constants are sometimes used for messages. There are a lot of constants in the system. You retrieve these constants to display information. If you click on one of these, you can see what a constant is. So this is the constant name, and then you have the constant value that you would display on a window title bar, on a field description, any of that type of information. Data types is what defines the field. So every time we make a field, we have to give it a data type. Data types can be strings, integers, currency fields, numbers, drop-down list, a visual switch, a variety of different things can be a data type. As you can see here, this data type is a drop-down list. There are static values that are associated that are text. If we click on here, we have the defined static values. So every time I create a field that will be made up of this data type, these static values will go along with it. That's the value of Dexterity, that it utilizes objects over and over again, so I don't have to recreate that information or find out throughout the application where I have to make that change. So in the future, if I add a new 1099 type that I want to display in the drop-down list, I would simply add it to the data type and it would transfer throughout the entire application where that data type is used. Fields. Fields are the actual data elements of the tables that will be storing information. So this is what you want to use in application. Just like data types, fields can be reused over and over again. So they're separated from the tables. Before we can make a table, we have to create the fields and the values that we can reuse that same field over and over again without having to figure it out. A good example is customer number. We use customer number in multiple tables throughout the system. I don't want to have to create that customer number over and over and over again, so I create it once as a field, and then I reuse that customer number throughout the system. In the future, if I have to enlarge that field, I enlarge it at the field level, and throughout the system, the tables are updated. Give you an example of what a field looks like. I just give it a field name. The physical description is what is defined in SQL. So when you look at the table, you're going to see 1095 line description as opposed to the field name that shows in the GUI. As we're building applications, we see 1095 line description. And then down here, the data type. It's a string, 255. And if I open this up, you can see what I'm talking about. The control type is a string. Keyboard length is 255. Storage is 256. That's those Pascal string lengths. That's similarity between the two languages. Everything has to end in an even byte. Formats. This defines how things are displayed on the screen. So if I want a phone number, the account number, a segmented customer number, those types of things to display a certain way on the screen, I would create formats for those. So an example would be the account mask. So this format of the account mask is I want the 5 segments. If I have 25 characters in this for an account number, it's going to put dashes and separate those out into segmented values. I can do other things as well. I can eliminate trailing blanks, eliminate leading blanks, make this format numeric only, meaning that when I use this field and I have this format associated with this field, only numbers can be entered into it. Alphanumeric only characters and numbers can be entered. I can't use periods, exclamation points, things like that. Or if I want it to be uppercase only. If this happened to be a numeric format type as opposed to a string, so composite is considered a string. If I change it to a numeric or currency, then these fields over here will become available, and I can define specific things here. The number and decimal places, how the negative symbol should appear, is it unsigned, thousands, and those types of things. Global fields are things that you use that you want to share information throughout your entire application. As we all know, if we have a little bit of programming background, a lot of procedures and things that are done on Windows are single-minded in purpose, meaning that I define a field in a window or a global script. That field loses its values as soon as you exit that form or you exit that procedure. If I need information to transfer between procedures, I want to temporarily store it, I could create that as the global variable and then share that information across different procedures, forms, and things like that. Icons, these are the things that show up on the screen. Example of an Asian icon. It's not really displaying very well, but that comes from the GP icons. DLL, let's see if we can find one here. Yeah, we're not going to see anything here. But these are in the DLL file here. So it's a library of icons that displays in the system. So when you want icons to appear in Dynamics, you would use this icons DLL or create your own icons DLL and load them into the Great Plains application. Libraries, and we're not going to get this in this part series, but these are how you use DLLs or COM objects within Great Plains. You define them as a library, import those resources in here so you have them available in Great Plains so that you can use those external DLLs or COM objects with your Dynamics applications. Messages. Messages are things that you want to display back to the user. These are common messages that prompts, things that you want to notify the user about. It could be a saving message, it could be a message, as you see here, Ken Jackson, that they just store in the database, something for a report, something for checking, but any type of message that you want to retrieve in the system. It's a function in the system called getMessage. You pass it the message ID, it returns the text, and then you can display that in the message box. That's what messages are primarily used for. Native pictures, these are any pictures that you want to use on reports or also display on the screen. So the about picture for Microsoft Dynamics, how you use this is you would basically have a JPEG, you would copy it and paste it right into the screen. So you create a new native picture definition, paste it right in here. Then that name is available and can be used on any screen or report within the Great Plains environment. Native pictures and pictures are pretty much the same concept. Strings. There's quite a few strings, so it takes a couple seconds for it to appear. So these are all the strings that are available in the system that you can use. Same thing, it's an ID. We don't use them that much. Don't really have a need for them. But beginning, range, balance. A lot of these are used in reports. You use a string ID to display these values. Same concept as messages. We don't use them that often. Haven't seen a lot of value in them. Tables. This is where we actually store the data. So we go down here and let's find the RM Customer Master Table to give you an idea of what it looks like. We'll go through the different components of a table. Since we're all familiar with customers. So here is the RM Customer Master Table. So let's go through some of these components. So when we're creating a table in the system, we first start off with the table name. So this is the internal technical name of what we're storing. So here we have RM underscore customer master, and there's certain rules in Great Plains on how we define table names, physical names, and things like that. So here we like to start things off with RM for the module that we're working with. So receivables management, PM for payables management, SOP for sales order processing, and that type of thing. A little description here of what that table name is, obviously it's customer, and then you'll see quite a bit throughout all the other tables in the system. You have MSTR if it's a master, work if it's a work table, HIST if it's a history table, open, that type of thing. You'll see. Display name, that's what the user would see if they're using a report writer, and you would see when you're looking up tables in the system. And the physical name is what's created in the SQL Server database. There are rules here that Microsoft likes you to follow. To give you an example here, all the master tables, setup tables are generally from 100 to 9999. Makes people easy to understand the table scheme, what's stored in those. You'll have some summary tables in there as well, as far as in that range. The 1000 series are generally for work tables, so you're entering transactions before you post them and things like that. The 2000 series are open tables, so those modules where you have open AR, open AP, things like that. We go into 2000 series, that's where you typically see those. The 3000 series are your historical data. That's where you see historical AR transactions, GL history, AP history, those types of things. And then 4000 and greater are your setup tables. Your receivables management setup tables. You may see your payment term setup tables. Those types of things are in that series. So it makes it very easy once you get comfortable with that architecture and you need to find data for a customer and a module you're not familiar with, that we all follow the same architecture as far as naming conventions of tables. Now when we're creating a table here, we can define what series we want. This was important early on when we were dealing with btrieve and ctrieve databases early on. What this would do, it would put the tables in, or the files that were created, in a structure in the environment based on the folder. So you had a sales folder, purchasing folder, and things like that. Not quite used as much. It is nice if you label your tables in the correct series. So in the table resource descriptions, other users can find your tables very quickly. Some developers will throw all the tables down into third party. It makes it a little difficult to understand what's a sales table, what's a purchasing table, if your customization is fairly complex. But so if you can adhere to the series, it makes it very helpful on trying to find your tables. You have the database type as default. As you can see here, you have a couple different options. Nobody really uses C-tree or P-SQL. SQL is the default now. And then they have this one option called memory. Some people like to create memory-only tables. They go away once the application is closed. And then you can restart it when the application starts up. Can be useful in some things for memory table. I don't use them very often. It can get a little out of control and use up a lot of RAM and cause your application to crash if you don't pay attention to it. Over here we have our keys. So if you're familiar with databases, these are all the indexes. The idea is to define your indexes to get your best performance out of your application. You don't want to create too many indexes in fear that it would slow down your application. So if you look at index here real quick, you pick the fields that are associated with your table on what you want indexed. You put down some of your options down here, how you want to have the index function. Do we want it to be our primary? So it does have to be a primary index. If we uncheck primary, as you can see right now, I can still create an index and still make it unique. If this was a segmented index, meaning I had multiple fields in here, I can put some segmenting options in here on how I want to sort. And then down here in Great Plains, for tables, they create table store procedures. It improves performance because it batches up the selects for inserts, deletes, selects, next, and things like that. You can disable those if you don't want to use those. Most people do. It does improve performance of your database application. Here are some options for the tables. Allow active locking. That's not really used that much for SQL. That was a C-tree and B-tree functionality years ago. If you had a table that you wanted to use a restriction, which is kind of nice, where you can restrict data based off of another value, so only that data. An example would be if you had